Okay, so now let us look at questions 5. Okay, questions 5. So first of all, I want you guys to sketch a free body diagram. So how are you going to sketch a free body diagram based on the situations given? So you look at the questions. Okay, so now you have an object. This object is the yeah, it's a children's and sleds. Okay, two of them they combine together and then they give you 50 kg. So they form. Okay, this is a diagram. It forms an object which is equivalent to 50 kg. Then it slides down a hill with height of 0.46 meter. So now you have a hill. Okay, so let us see how are we going to sketch the diagram. So this is the hill. And then according to the question, it tells you this hill, it is 20 degree above horizontal. All right, so 20 degree above horizontal. We have a horizontal surface and the hill is 20 degree above it. So basically this is our diagram. Okay, our diagram. Oops. And then, yeah, this is the height. All right. So the height of the hill is 0.46. It means this part. Okay, this is the height of the hill, 0.46 meter. And then initially, our object, it start from rest. So start from rest, it tells us u is equal to 0 meter per second, which then also gives us another piece of information, which is a k initial equals to 0. Okay, because when there's a no velocity, when velocity is equal to 0, there's no kinetic energy. Okay, and then when it reaches the bottom, okay, when it is at the bottom, what happens? Now this at this position, it has a speed v equals to 2.6 meter per second, right? And then at these positions, now we have to determine where is h equals to 0. So again, I'm going to take the ground as h equals to 0. Okay, so this is my h equals to 0, in which it means at the bottom, the object has a speed of 2.6 meter per second, but then because of h equals to 0, my u final is now equals to 0. Okay, my u final is now equals to 0. And according to questions, now this object, it experiences a loss in energy. Okay, so thermal energy is lost. So you have energy loss in these questions. Our main task is to calculate the energy loss. Okay, energy loss due to frictions. So how are we going to form equations then? So as usual, we are going to start from conservations of energy. Okay, the principle of conservations of energy. Summations E initial equals to summations E final. So according to questions, now these questions, what do we have? We have kinetic energy and we also have gravitational potential energy. All right. Therefore, what am I going to do first? I'm just going to write down all of them in my equations. So K initial plus UG initial and plus energy loss. Okay, energy loss. According to these questions, it comes with energy loss. And then plus K final equals to K final plus UG final. So done. Okay, I don't have to add the US initial and US final because there's no spring in my questions. Okay, now what am I going to do? I'm going to simplify my equation, okay, based on diagram. According to diagram, my K initial is 0, so I'm going to cross it out. And then U final is 0, so I'm going to cross it out. Okay, so done. So this is the remaining parts of the equations. Okay, then I'm going to expand it. So initially, okay, my UG initial is MGH initial plus, well, according to questions, the energy loss is due to frictions. Okay, therefore to make it easier, I'm just going to write it down as a WF. Okay, work done by friction, because it is the energy that is being used, is the work that is being done to overcome the friction along the surface, which is then equals to half mv squared. So again, if you look at these equations, you cannot cancel out the m from the equations. All right, therefore we need to substitute the value. So the values given is 50 kg. So 50 times 9.81 times the height. So initially the height is 0.46 meter. That is the height of the hill. Okay, so 0.46 meter, and then plus WF, the energy loss, which is equals to 1 over 2 times 50 kg times V, no, I have the V, right? Times the V final, which is 2.6 squared. So rearrange the equations. Eventually, you are going to obtain WF equals to negative 56 joule. All right, so against the negative sign here, it tells you this is energy loss. All right, this is the work done to overcome the frictional force. Okay, the work done to overcome the frictional force. Now, according to the second part of the question, it asks you to determine the frictional force. All right, which means, what do we need right now, okay, is we need to expand these equations. So a frictional force, again, is equals to Fs cos theta, which is equals to negative 56 joule. Now, our task is to determine the frictional force, which is F. But do we have the S and the angles? Okay, do we have the S and the angle? Then we have to go back to the question. Now we go back to questions. Our object is sliding down the hill. So this is the directions of the S. So which means we need to calculate the displacement traveled by this object. How to calculate the displacement traveled by this object? You look at the diagram. You have a right angle triangle, right? You have a right angle triangle in which it means the S, the displacement, can be determined by using the sine function. Okay, so sine 20 degree is equals to 0.46 over S, the displacement traveled, which is the hypotenuse. So S is then equals to 1.34 meter. So this is the values that we're going to use in our calculations. So now that we have S, how about the theta? Okay, so remember, when it comes to work done, angles in the equation, okay, is the angles between, frictional force and displacement. So since our object is sliding down the hill, therefore the frictional force will be going towards opposite direction. Okay, so S and F, they are pointing towards opposite direction. So which means angles in this equation is 180 degree. So F times with S, which is 1.34 meter, cos 180 degree, which is then equals to negative 56. Okay, which is then equals to negative 56. And therefore, by rearranging the equations, F is then equals to 42.26 Newton. So that is how you solve it. Okay, the crucial point in this question is whether you know how to determine the value for S or not. So S can be determined by using trigo function, which is sine 20 degree equals to 0.46 over S. Okay, so the distance traveled by my object, okay, along this inclined surface is 1.34 meter. All right, so this is questions 5. So now I give you some time to write it down. Okay, let me. Yeah, I'm going to zoom in. Okay. So this is how you solve it. Okay, so I give you 2 minutes to write it down before we proceed to questions number 6. So questions number 6 is slightly more complicated. Why? Because it involves 2 objects. Okay, because it involves 2 objects. So 2 minutes for you to write it down. If you are done, then you can try question 6 first. All right, so now let's look at questions number 6. Okay, so this is the last questions that I want to discuss today, okay, because these questions will spend quite a lot of time so explaining. So the coefficients of the frictions between 3 kg blocks and the surface is 0.4. Okay, so if the system starts from rest, calculate the speed of a 5 kg ball when it has fallen a distance of a 1.5 meter. So how are we going to calculate it? First of all, we have to determine where is our h as usual. Okay, where is our h as usual? So the h, okay, let us draw the diagram first. So this is my ground. Okay, I'm going to take it as my ground. So h is equal to 0 on the ground. All right. And then how about the object? So this object is located as a height, the dimensions. Okay, so it has fallen a distance 1.5 meter. Okay, the ball fallen a distance 1.5 meter. So the final positions is after minus 1.5, but we don't have the initial positions of the ball. Okay, let's assume the initial positions of the ball. Okay, I'm going to redraw the diagram. Okay, I'm going to redraw the diagram. I need 2 diagrams in these questions. So with the ground as a h equals to 0. So the ball is too big. I'm going to resketch it. So this is the table. Okay, and then this is the ground. Oopsie. The tables, the ground. Okay, and then this is a ground, and then it's a table. Okay, so initially I have an object here, and then, okay, this is my ball. So initial height of the object, I'm going to take it as x, because I don't know the original positions, the initial position. Okay, so this is the initial, and then this is the final. And now what happened if, okay, after it drops 1.5 meter. Okay, so according to the questions, the ball, it drops by 1.5 meter. Okay, it has fallen. So it means that the height now is x minus 1.5. You don't know the initial positions, but what you do know is that this object, it has dropped by 1.5 meter. Okay, so this is the information that we have. And now if you look at these questions again, you have 2 objects. Okay, you have 2 objects. Object box and object ball. All right. And if you apply the equations of conservations of energy, summations E initial is equal to summations E final, you need to take into considerations the energy of both objects. Okay, not just for ball. If you just look at ball, then it is wrong. Okay, you have to take into consideration both objects, because now these 2 objects, they are acting in a system. Okay, they are acting as one whole system. So what are we going to do now? Okay, so you look at the questions again. It says you got coefficients of friction. Okay, means that there is an energy loss. Energy loss for object box. Okay, so object box, it experiences an energy loss. And then this object is dropping. So one is moving on the surface, okay, and then one is dropping. Both of them, they are moving, just that one involves kinetic energy and one involves potential energy. So in these questions, if you look at the questions again, there's no spring. Okay, so it becomes easier for you, because if you got one more spring, then this will be a very, very complicated questions. So what am I going to do now? I'm going to form equation first. But how to form equation? Okay, you look at the questions. Now you got 2 objects. Okay, object box. Okay, let us see. So in my equations, I'm going to expand it. First, I need to take into considerations the energy from box. So K initial plus UG initial. I'm going to close the bracket first. And this is for box. Okay, this is for box. And then plus, okay, what am I going to do next? I'm going to look at what happens to the ball. Okay, so I need to take into considerations as well the energy involved ball. So bracket K initial plus UG initial for ball. Okay, so I need to take into consideration the energy for both of them, not just for one of them. Okay, I need to take into consideration the energy for both of them. And of course, you can write Ki box plus Ki ball, and then plus UG box plus UG ball. It is up to you. All right, this is how I write it. So some of them, they like to write it as Ki box plus a Ki ball. So this is the part for kinetic energy plus the UG initial box plus UG initial for ball. Okay, so this is the part for potential energy. Also can, okay, also can. Just that I like to do it by item, by object. Okay, some of them, they like to do it by energy, but I like to do it by object. So plus, now because you have work done by frictional force, okay, because this surface, it comes with a friction, therefore plus W friction. Okay, so how about the vertical object, the ball? No, you don't have to take into considerations for the ball because there's no frictional force involved ball. And then the question, it doesn't mention anything about energy loss involved the ball. Okay, so we have only energy loss involved the box. Okay, done. Then that is equals to what? Equals to kinetic energy again. Okay, equals to the energy, final energy for the box again. So kinetic energy F plus UGF for the box. Okay, and then plus. Okay, plus then we look at what happens to the ball. Okay, so K final plus UG final for the ball. All right, so now I've taken into considerations the energy for all of the object. Okay, the energy of all of the object. So next, okay, what am I going to do? I'm going to analyze the questions. So it tells you this whole things, it start from rest. Okay, it start from rest, and then it has a final speed, and that is what we want to calculate. So what happens now? So initially object is at rest, means that you can straight away cross out the kinetic energy for initial. Initially, there's no kinetic energy because my object is at rest. All right. And then how about the potential's energy? So potential energy for my object box, okay, for object box, I can just ignore it, okay, because it doesn't move in a vertical motion. So there's no change in G. So for box, okay, it doesn't have any potential energy. So I'm just going to cross it out, okay, because box is just moving along the horizontal surface. So no vertical motion, no change in the vertical position. So there's no change in potential energy for the box. So initial could be the height of the object. Okay, if you want to say initial is h, final is also h. Then why do you need to take calculate it? Okay, so you don't even have to calculate the u for the box. But of course, if you want, go ahead. Okay, that would just be an additional step for you to rearrange the equations. Then they are equals to 0. Okay, so basically what happened is UG final for the box minus UG initial of the box is equals to 0. Why? Because they start from a h and then they end at h, same height. Okay, that's why straight away I cross it out because there's no change in height, so I assume no potential energy. So let's see the remaining terms. So initially my object ball, okay, it starts from x, so I have UG initial. And then how about final? Okay, final, my object, the box is moving with a velocity, so I keep the kf for box. And then ball also moving with a velocity. It hasn't reached the ground yet, so yes, it has a non-zero velocity and a non-zero u. Okay, it just tells you the object drops for 1.5 meter. But you don't know whether after the 1.5 meter, after it has fallen for 1.5 meter, does it still have any the heights or not? Okay, still comes with the height or not. Okay, so what am I going to do next? Okay, what am I going to do next? Let's see. Okay, so this x, I keep it as unknown, okay, because questions doesn't tell us whether the height of the ball is 1.5 meter or that is the final, okay, the final is on the ground or not. Okay, so we keep it as unknown. Okay, now let's see how are we going to solve it. So initially my ball, okay, M for a ball, and then G and an X, okay, the unknown height, and then plus, okay, plus, now I want to calculate the speed, okay, but if you look at the questions, I don't have the energy loss. What I do have is just the coefficients of kinetic frictions. So let us recall, okay, what is the formula for W? Okay, what is the formula for W? So for W, okay, W friction is equals to Fd cos theta. But then again, if you look at the questions, I'm not given the frictional force, right? But what I do have is mu. So F at the same time is equals to mu n. So mu n, okay, I'm change the symbol. It should be Fs. Okay, so it should be Fs, and then mu ns cos theta. Okay, mu ns cos theta. But then I have one more question. Do I have normal force? Well, I don't have normal force, but I can calculate it. So based on the diagram, for this box, the vertical component and, okay, the y component, it has only n and mg. There's no other forces acting along the x component, and my object, it doesn't move along the vertical component. Therefore, what can I say? Summations Fy for the box, okay, is equals to 0. Vertical component. Therefore, n is equals to W, which is then equals to m box G. So from here, you can then calculate the normal force, okay, the normal force of the box. Okay, so after you got the n equals to mg, and then you sub it into Wf equals to mu n as cos theta, then it ends up, this is our end product. So mu m box gs, okay, mu m box gx, and then times with cos, okay, 180 degree. Okay, cos 180 degree. Okay, so my S, okay, the S that I have right here is actually equals to the X. Okay, I would say it's equals to X. Because according to the question, it tells you the object, it moved by a distance X. Okay, it moved by a distance X. So which is then equals to, okay, equals to what? K final. K final is my 1 over 2, okay, 1 over 2 m box, and then the v square plus 1 over 2 m, yeah, 1 over 2 m ball, okay, m ball, v square. Oh wait, I got a mistake just now. It's not x in the first equation. It should be 1.5. Okay, so I'm going to okay, I'm going to leave it as s first. Okay, but s is equals to 1.5. Why? Because it tells us our ball it moved by 1.5 meter. Then obviously my horizontal displacement s is also equals to 1.5 meter. Right? So this one, it drops by 1.5 meter. So my horizontal box also moved by 1.5 meter. Okay, and then this one continue M ball, and then G x minus 1.5. Okay, x minus 1.5. So this is my equations. Okay, this is the equations after I expand it. Okay, I expand the equations above. Okay, now I'm going to plug in the value. Okay, I'm going to plug in the value. So how to plug in the value? Okay, now let's see. So M ball, okay, the ball is 3 kg according to the questions. So 3 kg, 9.81 times with x plus coefficients of fusions, mu is a 0.4 times with the mass of the box. Aha, I make a mistake here. Mass of the ball is not 1 it's not 3. Okay, it's not 3, but 5 kg. Oops. So M ball is 5 kg. M box is 3 kg. Okay, 9.81. And then the S, it travel by 1.5 meter. And then cos 180 is -1. Okay, -1. So which is then equals to 1/2. Okay, again, the box is 3. And then V squared plus 1/2. And then the ball, which is 5. V squared plus, now the ball again, so the ball is a 5. And then 9.81 x minus 1.5. All right. So if I rearrange the equations, okay, actually you will see that x and x, they will cancel out with each other. Okay, x and x, they will cancel out with each other. Why? Because now if you look at the equations, okay, I'm just going to expand this two part for you. Kalau kamu tengok dua part ini. Okay, so what am I going to do with these two parts? I'm going to rearrange them and then put them together, in which it will give me 5 and then 9.81. Okay, so what is going to happen is that there will become x minus x plus 1.5. All right, because they have the same factor. So x and x minus 1.5, you can just subtract them. Okay, you can just subtract it because you move to the other side. So plus, okay, 0.4 and then 3, 9.81, 1.5, -1, which is then equals to 1/3, 1/2, 3v squared plus 1/2, 5v squared. Okay, so the crucial part is whether you know how to cancel out the x. Okay, how to cancel out the x. All right, and then what do I have at last? So if you rearrange the equations, okay, I leave the rearranging equations for you. You will get V is approximately equal to 3.7 ms -1. Okay, my answer, I obtained 3.67. So I'm not sure what is the values that you are getting. All right, so here I think it's a 73.575 plus -19.62, which give me 4v squared. So V is a 3.67. Okay, approximately equals to 3.7. So you try to solve it, see whether you can get the answer or not. All right. So this question actually is not hard. Is if you understand what does it mean by principle of conservation of energy. So principle of conservation of energy, it means the total energy in the system before equals to the total energy in the system after. So you need to identify how many objects do you have in the system. How many object is giving you the energy in the system. So in this object, in these questions, I have two moving objects, which is the box and the ball. So when you calculate the total energy, you need to take into considerations the energy coming from the box and also the energy coming from the ball, right? So you cannot treat them, you cannot calculate them separately because when it comes to summations E initial equals to summations E final, you are looking at whole system, but not by object. Okay, not by object. You're looking at whole system. So whole system, you need to calculate everything. So you need to include everything in the equations. Okay, so I give you 5 minutes to write it down. Okay, no, actually not 5 minutes. So I think that's all for today. I'm not going to move on to the next subtopic. Okay, because this question, it marks the ends of the conservations of energy. So next part, next exercise, we have a work energy theorem. Okay, it's a new subtopic. So I don't want to start a new subtopic today. I will stop right at here. Okay, just at the conservations of energy. So next lesson, okay, most probably I will have an additional class, extra class with you again on Saturday. Okay, because unfortunately next week I have workshop again. So I won't be around from Tuesday until Thursday. Okay, so most probably I will have an extra class again with you on Saturday from 11 to 1 as usual. Right? So now once you write it down and you understand everything, then you may leave the class. Okay, then you may leave the class. That's all for today.